Hello everyone again and welcome to this particular video where we're going to talk about reaction mechanism of the tetra alkyl alcohol with concentrated acid. Sometimes given the chemical reaction equation that shows a tetrapentyl alcohol with all the 5 carbons, where we have a carbon center that has all 3 carbons attached to it and then an hydroxyl group. This is actually known to be soluble in water, also known as tetra-amyl alcohol, also abbreviated as TAA, which is well known anesthetic, and it's also a positive allosteric modulator for GABA A receptors. Now, this, when subjected to a strong acid, usually hydrochloric acid, when that is in water, it forms hydronium ions and that of the chloride ion. So this reaction in the presence of water, you notice, leads to the formation of a tetrapentyl chloride, which is actually insoluble in water. As a result, this separates out from the aqueous phase into a more organic phase, and this is then actually distilled to purify. Now, this actually notice leads to the formation of 2 water molecules. Now, by inspection of this reaction, the main product is actually gotten from a substitution reaction where you have the chloride is in the place of the hydroxyl group, as you notice from that particular equation. Now, looking at the mechanism, we have 3 steps that leads to the formation of the main product right there. First is a prostate acid base reaction between first the tetrapentyl alcohol acting as a base and accepts a proton from the hydronium ion, where the chlorine ion is actually known to be a spectator. Now, as a result of the electron arrow going from that oxygen lone pair to attack that particular hydrogen on the hydronium, that hydrogen bonding with the oxygen forms a lone pair on the oxygen, thereby making the former charge on the oxygen to be neutral. This at equilibrium leads to the formation of tetrapentylioxonium, which is actually protonated alcohol that is now as a conjugate acid of the prostate base. However, on the other side, the prostate acid, which is the hydronium, has its conjugate base, which is known to be water. Now, the second step is that particular tetrapentylioxonium is actually performing a reverse Lewis acid base reaction. What do I mean by that? In this step, the tetrapentylioxonium has a formal charge on the oxygen of the protonated alcohol. This positive charge on the oxygen is actually weakening the carbon-oxygen bond on it, thereby drawing the bonding electrons in the direction of the positive oxygen, because that oxygen is in need of electrons. That is why that pool of electrons is actually existing right there. As a result, breaking hydrolytically leads to the formation of the carbocation and the formation of a water molecule, and this carbocation now moves into the third step, which is the Lewis acid base reaction, where we notice here that the Lewis acid is a carbon cation and the Lewis base is now chloride. Now you might be wondering, why is chloride acting as a Lewis base and not water? Now, when you look at the formation of the tetrapentyl chloride, this formation is actually gotten from the carbocation, but you know that not all carbocations move on to form this product. For some reaction, in this case, this particular part, water, which is also known as H2O, acts as a Lewis base, and this actually will lead to the protonated alcohol to be formed again. It is, and I would say it will dissociate again as a result and become carbon cation. Now, over time, as equilibrium establishes, the formation of the chloride product, which is the step 3 of this reaction, will be favored as it separates from the reaction phase into its non-aqueous phase. So that is about it for this particular video, which deals with the reaction mechanism of any form of tetraalkyl alcohol with concentrated acid. We notice the 3 steps, which are the Boston acid and base reaction between the tetrapentyl, in this case alcohol, with the acid, which is the hydronium, and then step 2 is the reverse Lewis acid base reaction, and finally we have the Lewis acid base reaction, which leads to the formation of the tetraalkyl chloride. All the same, thanks for following me through this particular video. Hope you're able to understand this. Please hit the comment down below. Let me hear your thoughts about any other reactions that you want to see on this channel and the mechanisms associated with those particular reactions. And see you all on my next video. All the same, stay smart and believe in yourselves.